In this video, I'm going to complete 3 exam questions where I will have to solve simultaneous linear equations using algebraic methods. These are the 3 questions that I will be completing, but before doing it, I will do a quick review of the basics you need to know to solve this type of problems. The common methods for solving simultaneous linear equations are graphically, which involves using a graph, and substitution and elimination, which are the 2 algebraic methods that we are going to use in these examples. First, we will revise some vocabulary used with equations that I'm going to be using in this video. This is an equation, a mathematical expression that is equal to another mathematical expression. A term is a mathematical expression separated by plus or minus sign. In this example, we have 2 terms on the left-hand side of the equation and 3 terms on the right-hand side of the equation. A variable is a letter that represents an unknown number. The most common letters that we are going to use in equations are x and y, but it could be any other letter. A constant is a term that does not contain any variables. It's a number on its own. A coefficient is a number in the same term as the variable, that it's multiplying or dividing the variable. You need to know how to rearrange an equation, how to manipulate an equation to be able to leave a variable on its own on one side of the equation. To do this, I'm going to explain 3 basic techniques: addition and subtraction, combining like terms, and multiplication and division. Addition and subtraction. We have to use this technique to isolate a variable on one side of the equation. You can add or subtract the same quantity from both sides of the equation. Here we have an example: x minus y equals 7. I want to leave x on its own on the left-hand side of the equation. I need to get rid of the minus y. To do this, I need to add y on both parts of the equation. Minus y plus y is 0. So now the equation is x equals 7 plus y. This is another example. I will leave x on the left-hand side of the equation and the rest on the right-hand side of the equation. I need to get rid of these 3, so I will need to minus 3 on both parts of the equation. 3 minus 3 is 0, and minus 4 minus 3 is minus 7. So the equation now is x equals y minus 7. Combining like terms. We have to group terms that have the same variable raised to the same power, and we have to group constants, terms without a variable. In this example, we have 2 terms with an x. If we add them together, we have 3x. And on the other side of the equation, we have 2 constants. If we add them together, we have minus 5. So now the equation that we have is this. Now we are going to apply the 2 techniques, one after the other: addition and subtraction, and combining like terms. In this example, before combining like terms, we need to rearrange the terms so they are on the same side of the equation. I'm going to put all the terms with an x on the left-hand side of the equation and the constants on the right-hand side of the equation. I need to get rid of this minus 5 here, so I'm going to add plus 5 on both parts of the equation, and on the other side I need to get rid of this, so I need to minus 5x, and I will do it on both parts of the equation. And now I need to continue combining like terms. 7x minus 5x is 2x, minus 5 plus 5 is 0, and 3 plus 5 is 8, 5x minus 5x is 0, and the simplified equation is 2x equals 8. multiplication and division. This is another technique that is going to help us to isolate a variable. You can multiply or divide both sides of the equation by the same number. We are going to continue with the previous example. 2x equals 8. We need to leave x on its own on one part of the equation. To do this, we need to get rid of this 2. If we divide by 2 both parts of the equation, on the left hand side I will have 2 divided by 2, which is 1, and on the other side I have 8 divided by 2, which is 4, and we found out the value of the variable, that it's 4. Another example. If I want to isolate y, I need to get rid of 3. If I multiply both sides of the equation by 3, on the left hand side I will have 3 divided by 3, which is 1, and 1 multiplied by y is y, and on the other side 12 times 3, which is 36, and this is the value of the variable y. After this quick revision, we can start with the algebraic methods for solving simultaneous linear equations. These are substitution and elimination. We will solve these two simultaneous linear equations using both methods. First, we will be using substitution. We need to rearrange one of the equations to leave one variable on its own. Ideally, a variable that has no coefficients, no numbers that are multiplying or dividing it. If it has coefficients, it's more complex to rearrange. Then we will substitute that variable into the other equation. I will carry out this example. I will start with this equation and I'm going to leave y on its own. So y equals 2, and I'm going to plus 2x on both parts of the equation. So here I will have minus 2x plus 2x, which is 0, and on the other side plus 2x. Now this variable y, I'm going to take it here and I'm going to substitute it. So 2 plus 2x, and now I can continue, plus 4x equals 14. Now I can combine these two terms, 6x equals 14, and I'm going to minus 2 on both parts of the equation. Minus 2 plus 2 is 0. So 6x equals 12. Now if I divide it by 6 both parts of the equation, x equals 12 divided by 6, which is 2. And now I can find out the value of y in this equation. Y equals 2 plus 2 times x, which is 2. And this is 2 plus 4 equals 6. So the answer is 2, 6. Now I'm going to do again the same example, but now using the method of elimination. Now I'm going to solve again the same two simultaneous linear equations, but this time using the method of elimination. To do this, I need to make sure that the variables are lining, which they are. Y has the same coefficient in both equations, which is 1. But I'm going to multiply this first equation by minus 1. So in this first equation, y is negative, and in the second one is positive. So I will start multiplying by minus 1 every term in this equation. This means that the sign of the terms is going to change. And the other one will be the same. Now I can add them together. Y minus y, 0. 4 plus 2, 6. X equals 12. If I divide by 6 both parts of the equation, 6 divided by 6 is 1, 1 times x is x, equals 12 divided by 6, which is 2. And now here in this equation I'm going to find out y. Y minus 2 times x, which is 2, equals 2. Y minus 4 equals 2. If I add 4 on both parts of the equation, y equals 6. And the answer is 2, 6. I'm going to continue with these two examples where I'm going to use again the method of elimination. In this first example, we can see that the coefficient of y is different. In this first equation is 2, and in this second one is 1. I'm going to multiply this equation by 2. So I will have to multiply each term by 2. So I will have 2y minus 8x equals 10. And what I'm going to do, the other one, I'm going to times it by minus 1. So the signs will change. Minus 2y plus x equals minus 3. And now I'm ready to add this. 2y minus 2y equals 0. Minus 8x plus x is minus 7x. And this equals 10 minus 3 is 7. If I divide by minus 7 both parts of the equation, this is 1 and this will be minus 1. So x is minus 1. Now I'm going to substitute this value here in the first equation. So 2y minus x, x is minus 1, equals 3. 2y minus minus 1 is plus 1, equals 3. 2y, if I minus 1 on both parts of the equation, here I will have 3 minus 1, which is 2. And y will be 2 divided by 2, which is 1. So the answer is minus 1, 1. In this example, we can see that the variables are not lining up. So I'm going to rearrange the equations so they line up. The first one, for example, I'm going to put first x and then y. Y is on the right hand side of the equation. If I minus y both parts of the equation, I will have this and nothing on the other side. And if I minus 2 both parts of the equation, I will have this. I'm going to do something similar here. First, the x with its coefficient plus y equals 6. Here we have minus y plus y, which is 0. And here 6 minus 4 is 2x equals 6 minus 2, 4. So x equals 4 divided by 2. Because if I divide by 2 both parts of the equation, here I will have 1. And this is 2. Once I have this, I can take it to one of the equations. I'm going to choose the first one. Y equals 6x, 6 times 2, because x is 2, plus 2. And this is 12 plus 2, which is 14. So the answer is 2, 14. And now we are ready to start solving the first exam question. It says, the contractor has been provided with estimates for the cost of the facing bricks and concrete blocks to construct the office building. The costs are linked by the following two simultaneous equations. F is the price of one facing brick, C is the price of one concrete block. So we need to calculate using an algebraic method the price of one facing brick and one concrete block. These are the two equations where F is a facing brick and C is a concrete block. I'm going to rewrite the equations but without the symbol of the pound because it may be confusing. The method of substitution works well when one of the variables has no coefficient, and here all the variables have coefficients. I'm going to use the method of elimination. I need to have the same coefficient for one of the variables. I'm going to focus on F. If I multiply this first equation by 3 times 400 is going to be 1200, so the coefficient will be the same. And this one I'm going to times it by -1. What in the equation is positive, now it will be negative. What is negative, now it will become positive. So I will start with the first one. 3 times 400 is 1200 F plus 3 times 200, which is 600 C, equals 3 times 540, which is 1620. And the second equation, I will multiply it by -1, so minus 1200 F minus 500 C equal minus 1470. Now I can add them together. This is going to be 0. 600 minus 500, it's 100 C equals 1620 minus 1470, which is 150. If I divide both parts of the equation by 100, 100 divided by 100 is 1, so C equals 150 over 100, and this is 1.5. Now I will substitute this value into the first equation here. So 400F plus 200 times 1.5, because C is 1.5, equals 540. 400F plus 200 times 1.5 is 300, equal 540. I'm going to rearrange. If minus 300 on both parts of the equation, I will have 400F plus 0 equals 240. And now if I divide by 400 both parts of the equation, I have that F equals 240 over 400, and this is 0.6. So the price of a facing brick is 0.6 pounds, and the price of a concrete block is 1.5 pounds. Now we can continue with the second exam question. The contractor has been sent 2 invoices for the electrical socket outlets used in the housing development. The fittings are a combination of single and double socket outlets. The invoices are represented by the 2 simultaneous equations here. S is the cost of a single socket, D is the cost of a double socket. Calculate the total cost of 150 double sockets. So here we have the 2 equations. S is a single socket, D is a double socket. I have copied the 2 equations but without the symbol of the pound because it could be confusing. So if I look at the 2 equations, we have no variable on its own, so it's better not to use the method of substitution. And I can see that d in the first equation is half of d in the second equation. So if I multiply by 2 this equation, and then I multiply by -1 the second equation, I will have the same coefficient in both equations, but with a different sign. So I'm going to start with the first equation, multiplying it by 2. 120s is 240s, plus 2 times 25d, 50d, and 2 times 285 is 570. The second one, I will multiply it by -1, so I will change the sign of all the terms. Minus 95s minus 50d equal minus 295.50. So now they are ready to be added up. 240 minus 95 is 145s, plus 50d minus 50d is 0, and this equals 274.5. If I divide both parts of the equation by 145, I have that s equals 274.5 divided by 145, and this is 1.89. Now I'm going to use this value on this first equation. 120 times s, which is 1.89, plus 25d equals 285. So this multiplication is 226.8 plus 25d equals 285. I'm going to minus 226.8 on both parts of the equation. So 25d equals 285 minus 226.8, which is 58.2. If I divide by 25 both parts of the equations, 25 over 25 is 1, so d equals 58.2 divided by 25, which is 2.328. The question was asking for the price of 150 double sockets. So the price of the double socket is this, so I'm going to multiply it by 150, and this is 349.2. So 150 double sockets are 349.2 pounds. And this is the third and last exam question in this video. The routes of the two roads have been plotted on a map and are represented by these two simultaneous equations. Calculate the coordinates x, y of the intersection of the two roads by using an algebraic method. You must show all your working. To solve these two simultaneous linear equations, I'm going to use both methods. First, I'm going to start with the method of substitution. I'm going to take this and put it here. 2x minus 8 equal x plus 3. Now I need to rearrange this equation to put like terms together. I will start putting all the x terms on the left hand side. If I minus x both parts of the equation, here I will have 2x minus x minus 8 equal x minus x, 0 plus 3. Now if I plus 8 both parts of the equation, 2x minus x, this is 0, equal 8 plus 3, which is 11. 2x minus x is x, and this is 11. Now I'm going to use this formula to find out y. Y equals x plus 3. X is 11 plus 3. This is 14. The answer is 11, 14. Now I'm going to solve it again, but now I'm going to use the method of elimination. The variables are lining up, and I'm going to multiply this by minus 1. The first one is this, and the second one I need to change the sign, and I can add them together. Y minus y is 0, equal x minus 11. If I add 11 on both parts of the equation, I have that x equals 11. And now I can substitute x in this equation. Y equals x, which is 11 plus 3, and this is 14. And the answer is 11, 14, which is the same as the one that we got using the method of substitution.